Good day, ladies and gentlemen. My name is Anton Karneliuk. The topic we'll discuss today is a closed-loop network automation. A couple of words about myself. So some time ago, I was a network engineer working for Vodafone in Germany. These days, I'm a network manager working for the HUD group, where I'm responsible for worldwide deployment and operation of data centers at the backbone. But besides working for some companies, I have a passion, and my passion is researching the complex technologies such as multi-vendor network development, deployment, operation, and automation. And as a mix of my experience that I have collected working for companies and blogging, this topic has come. Before we start speaking about any automation, so answering the question how we automate these things, we need to understand what we need to automate. According to ISO, the operational domains in the network there are 5, which is covered by the acronym FCAPS, which stands for Fault, Configuration, Accounting, Performance, and Security Management. Each of these domains has a certain set of the tasks which we do. For example, in the fault management, we have all the tasks that are related to network troubleshooting, network some kind of restoration activities when we have some sort of the outages. When we speak about the configuration management, obviously it's all the configurations that we have, day 0, day 1, so onboarding the new device, adding the services, connecting the customers, and so on. And so we continue this task. We could continue this list of the tasks for each and every domain. And once we have this list of the tasks, what we do in each and every domain, we could add the frequency, so how often we need to do this or that tasks, and this is the basis for our automation. So understand what is like the main our pain points where we do a lot of activities, what is the content of each activity. So about the closed-loop automation. So by now you should know what we want to automate. Let's take a look on the whole framework. So the closed-loop automation could be split in 4 phases. Each phase has certain tasks and protocols. It starts with the networks and it ends with the network, because like we're speaking about closed-loop network automation. The first phase is collection of the information. It might be all the information that we have in the network. Here, the rule is applicable, the more the better, because all this information is input for your analytics later on. We could collect the telemetry, so streaming telemetry, another quite popular topic these days. It could be something legacy like SNMP or syslog or any other metrics that we could retrieve from our network devices or NMS if we have information there that we also need to analyze. So there might be different collections apps, again, per type of the information we collect. This is the first phase. The second phase, once we collect this information, we need to normalize, so to put it in certain format that could be later on consumed and store it somewhere. This somewhere, when we speak about the closed-loop automation, is specific types of the databases called time series database. So perhaps some of you are already using that, some has heard about it. Specific databases which are kind of has normal tables, but timestamps to each and every set of the counters or set of the log entries, if you speak about the syslog messages, which is stored there and could be used later on. The third step or the third phase in the closed-loop automation is actually the analytics of the information that we store in the database. There are 2 major approaches to do this analytics. First of all is, or the first type of such analytics is batch-based analytics. In this case, our analytic app send on a constant like time interval that we define, that we need request to our time series database, grab the data and analyze it. The second approach is stream-based. In such a case, the analytic apps create a subscription on a specific information, specific entries in the database that's interesting to hear, and the time series database automatically passes the messages to the analytics app once it receives it itself from the collection app. Then analytics is doing actually analytics of this management of these messages. It could you could think about analytics apps as a kind of parser which could parse text messages, looking for the keywords, extracting the information, or working with numeric data, so performing some mass formulas or whatsoever. And once it finds what is necessary for our application or for our logic, so some triggering keywords or some thresholds crossing, it launches the responsive action. In the simplest form, the response action could be any kind of Bash or Python script or any other type of script or any other application that would do the necessary corrective actions in the network. So the closed-loop automation you could think about as an enhancement of standard automations that you might have in your network, any kind of Ansible, Python, whatever, with the ability to be triggered or to be launched on a certain condition in the network. That's why if you analyze what does it mean for our network, we're not replacing the protocols that we have in the network. We still run all our IGP or BGP or MPLS, VXLAN, EVPN, so anything that we run in the network, we continue to use it. We add additional brain to our network, which could analyze this information end-to-end, again, based on the requirement that we have. And once this analysis is done, it could trigger certain corrective action. It is important because we're adding this layer on top. If we lose the connectivity from our network to this analytics app or collection app, we doesn't lose anything in the network. So if we have some outages, the network continue to behave as continue right now. We just lose additional intelligence. During the experience that I was having building such a system myself, and working with vendors on building the service, such a system with the vendors' help, I have depicted for myself some insight that I want to share with you. First of all, regardless of if you're keen to build the system yourself or if you're keen to go together with the vendor, I advise you to start looking on their open source tool, the why. First of all, you could immediately start doing something. You don't need to purchase anything, and there are plenty of really great open source tools on the market for information collections, time series database, analytics, obviously response actions. This will help you to focus not on particular products, but on the logic that you want to develop and start trying if your logic is correct or if you need to correct the logic. Later on, you could decide to go anyway with vendors on your own, but you already will have a clear understanding how the components of the solution should look like and where might be the potential problems. The second one is a microservice approach. Again, that is how the applications are mainly built today in software development industry, and microservice architecture gives you certain advantages or building any kind of monolithic app. The advantages are the ease of scaling. So if you need to add another compute because like you're running off the resources, you can spin up new instances of the certain applications like of database or the collectors or the analytic engine, and without touching the existing system or just modifying the existing system, that you will have some more application connected to it. Second is given your application split into multiple pieces, you could play around with replacing one microservice with another. If you don't like one type of collector, you could replace it with another type of collector. You could add a third type of collector. This also adds certain level of the resiliency, because if you have a problem with the computer and you lose part of your microservice, you could easily spin up. Again, you lose just part of the application. The third, it's also a bit related to what I'm told in the beginning. We need to focus on the functionality rather than certain products. If you focus on the functionality, we first of all build our logic, then we start looking for the components. Sometimes I have seen there, not a very good example, when first of all we have a certain product from vendor ABC, product XYZ, and we start looking, okay, we have a nice product, how could we apply it? Probably to get a bit into the details, so as Linus Torvalds said, cheapest talk, show me the code. When we was building this application, or whether I was building the closed loop application myself, I split it into these pieces. You could see the pieces basically covering everything that we need in day-to-day network operation. So it's documentation, it's provisioning, all the infrastructure services we need for zero-touch provisioning, actually not only for zero-touch provision like DHCP, DNS, FTP, HTTP, what is particularly related to the closed-loop automation and what creates, say, a heart of the closed-loop automation system is the data collection, storage, and the analytics. Also, we have a visualization tool, which is necessary for people, but not necessary for closed-loop automation system as such. There is a link, so if you are interested in taking really look into the code, you could download it or take a look on the GitHub page to understand how each of these pieces could look like, and to understand if it's like interesting for you, how you could get some inspiration for your systems. I'm not related to any or not engaged with any vendors. However, to give you some ideas what exactly I was using, from a platform perspective, for building infrastructure, all the applications was running as a Docker containers. It's very easy to spin up, and Docker itself, if you're not familiar, is very easy to learn the platform and start building the containerized application. From the infrastructure layer of view, basically all the applications that you see, not only from the infrastructure point of view, are open source applications. From the closed loop perspective, I've taken a look and used the influx data tick stack, so besides the chronograph, obviously, which was replaced by the Grafana. Why? One of the things what I liked about that was that Telegraph has already built in a lot of various inputs that I need, like syslog, telemetry, and SNMP. And if something is missing, it's developing quite rapidly. It's a high probability that the corresponding collector would come, or like it's even possible to write it yourself. Another important thing is that it has built-in analytic apps, which is easily to start using, which is capacitor. So I know that they changed the product structure in the latest version, so therefore I'm not using Influx Data 2.0, but the previous one. We'll go through the call flow on a certain application, so we'll see how all these applications are working all together. From the documentation perspective, using Netbox, perhaps some of you also using a very nice tool, which has built-in very rich API, which allows you to grab any kind of data that you need from the network. Yes, provision response standard, probably the network toolkit that, not the network standard toolkit that is used for all kind of automation like Ansible, Python, Bash. The use cases that I have tested, and you could take a look also if you take a look from my GitHub repo. The first one is extending ZTP. What do I mean by the extended ZTP? In general, the process how ZTP looks like is you have a certain DHCP options where you add the link to the configuration file. That's quite typical for data center switches, and for enterprise switches, not so typical for service providers. However, typically, there are two types how this ZTP could be realized. The first one, in this DHCP option, the link is provided with to the standard configuration file with very limited information, such as credentials, perhaps to change the default one, some information about the SNMP, syslog server, and obviously the IP address that's received through the DHCP. It typically doesn't contain all the further information that you need, like configurations, routing protocols, configuration of the MPLS, configuration of the services. Another approach, sometimes people prepare in advance full configuration, so you need to invest some time in creating the full configuration, update the DHCP server in the form that for particular host you will have a particular configuration file which will contain the full configuration for the device. Using closed loop automation, we are solving a couple of problems. The first problem, as I said, not all the devices support the DHCP option with the full configuration file. Using closed loop automation, we rely on the syslog messages coming even not from the device, but rather from the syslog server. We'll take a look in the details in a minute, but we look for specific DHCP messages, we extract the information, and we trigger their standard configuration workflow, which we will do by default manually. So like we configure the device, request information from the documentation system, and so on. In this case, we could apply the TP process for all the vendors, even that does not default this DHCP option. The second use case is automated failure analysis. What does it mean? When we start any kind of troubleshooting, we typically have in our mind, probably the most advanced company has it written in a kind of instructions, what are the steps that we need to go through in this or that case. If we have a link outage, what we do? We connect to the devices where we have link outages, we search for the logs, perhaps we do some other show commands, then we analyze this like manually using our mind, the best tool for analysis anything, and make some decisions. The same is applicable for routing protocol outages or for any other issues that we have in the network. Long story short, we have a set of the show commands or any other way how we extract the information using netconf, restconf, whatever, which we analyze and create the list of the action that we need to do to fix it. There is no reason why this set of the show commands could not be scripted and automatically launched upon any network issues which would result for us having the proper syslog messages or any other type of information like streaming telemetry, what we collect from the network into our analytic app. Then creating this collecting information script and parsing this information, we could automatically generate the report for us, which says that was the issue, that information is collected, that is the status, like neighbor down, how long, if the interface is up, if we speak about the protocol, I mean, if you speak about the routing protocol outage and so on. And the first one, at least, will be automatically have all the information that you need to start doing some troubleshooting. Once you fine-tune this logic, you take a look further, perhaps you could add not only the analysis as a response action to a certain condition, but also some corrective actions if it's possible, like changing QoS policy, modifying MPLS tunnels, and so on and so forth. The third use case that I was looking for is analysis of the information that we have in our database. So in time series database, we define our own how long we would like to store this information. If it's just for 24 hours, if it's for 1 week, for 1 year. Having all this data in historical scale, we could do multiple things. The two most that I was looking for is analysis of the long trend data, just understanding why, not the why, how my utilization of the interface is growing, to understand when I would need to start either rerouting the traffic or start purchasing new line cards or something like this. Second is analysis of the short-term traffic spikes to understand if there is a, what is the general network utilization from the customers, or just to finding perhaps some conditions like customer outages resulting in spikes of TCP sessions, like rebuilding their sessions and so on. So this will give you insights into the network. It doesn't mean you cannot do it without a closed loop automation. You can, but it requires somebody to constantly look into the information you collected in the NMS, and sometimes people could overlook something or could focus on something different. Deploying such automated checks will help you to start getting more insights that you would be able to do manually. Let's take a look for one call flow, more details, just to understand how these things are working. The example here is about zero-touch provisioning, the first use case that I was mentioning. So it starts with, so the idea is simple. We build a network and we need to build a new switch. It's not only about the new switch. It could be even about the building completely full new data center or service provider network. It doesn't matter. So the first thing, before we start building anything, we need to prepare. The first thing is to put the information about our network element in our documentation tool. So I was documenting the netbox. It has its own data structure. Therefore, we document what would be the IP addresses on the device in future, what would be the software version, and so on. We also need to add here one important thing. We need to know MAC address, because we are using like configuration of the certain element. This could be added later on. There is also a possibility how to do it, but in this particular case was looking for specific MAC addresses. The second, once we have documentation in the netbox, we create the proper configuration templates. Obviously, the configuration templates would be created per vendor, and each vendor would require different set of configuration lines or configuration or netconf, whatever, how we configure these network elements. The third type, what is related to particular closed loop, we create a parser in our analytics application which looks for DHCP messages. More specifically, it looks for DHCP ACK, the last message in the DHCP flow, which also contains the IP address of the element confirmed. This IP address is used, or this IP address is transferred later on to our response action, and you will see how it's used in the automation scenario. So once we have prepared these things, the last step in the preparation, we take information out of the netbox. We update automatically the DHCP configuration, so we add mapping of certain IP address to certain MAC address. We add information of the DNS to allow for other devices to do the DNS resolution. We update the telegraph in terms of we start collecting the SNP information from the specific IP address, and we add automatically the new dashboard or to the existing dashboard in the Grafana, the graphs for the particular device. Then we start the process of the network deployment itself. So bring new switch to the data center or to our site. It starts this DHCP process. The DHCP process is working with a certain container, and this is an ISC container which has information, which has mapping for this IP address. Once the DHCP gets IP address, this message is passed through the syslog to the telegraph, and telegraph puts information in the influx DB. Influx DB, the capacitor creates a stream subscription for syslog messages, and all syslog messages go into capacitor. Particularly, we are looking for DHCP ACK. In DHCP ACK message, we extract IP address and we trigger the bash script with this IP address. The bash script in its turn launches the playbook with IP address, which is in its turn as a part of the Ansible playbook. It requests data from the netbox. It puts the IP addresses. It creates the template for a particular device, taking into account what is the vendor, and configuration is pushed to the network element. From this time, as we have everything documented in the netbox, the device is fully provisioned, and it's not related on any particular DHCP option. Device starts being fully operational, so it starts sending logs, SNMP, telemetry to corresponding telegraph messages, and the device is fully monitored. It's like fully operational. We could start connecting our customers there. Summing up what we have discussed, it's about the automation of your logic. The first thing, you need to clearly understand what you want to automate and how. You need to create a kind of algorithm, regardless of the programming languages. And in this algorithm, once you understand what are the steps in this or that tasks, you start looking which information you need to have it and where you get this information. From your database, from NMS systems, and so on. Having this information all together, you could start working on the particular automation. So creating, first of all, the response actions, certain scripts or playbooks or whatever, and looking forward which trigger you need to trigger this automated action. That's basically it. It's about automation, all your knowledge, automation about all your tasks, and it's only you who could start working on this and start looking for this. Thank you very much for your attention. Any questions?
Any questions for Anton?
Firstly, thank you for your talk. I know you mentioned that you're using ISC DHCPD and that you're scraping the logs for DHCP ACKs from syslog. How reliable have you found that for triggering your automation, and have you tried any other DHCP services like FreeRadius DHCP, which you could integrate with things like SQL data stores and things like that?
Okay, thanks for the question. in terms of reliability of the ISC DHCP, is quite reliable. I have seen some issues that sometimes the messages was duplicated. So, I mean, all the DHCP messages were sent twice, but
specifically, I meant the reliability of getting the information into the logs and being able to parse that out of syslog, rather than the reliability of the DHCP server itself.
No, I understand. So that's why I'm saying the issues that I have faced with IC DHCP server was it's sending logs sometimes twice. So it was sending 2 DHCP ACK messages for the same device. How I have fixed it, the netbox has a concept of the different state of the devices, and the part of their playbook, I was changed the state of device from the planned to active side, and upon the, if we have this false positive scenario when we get in the log twice, it was checking, okay, in inbox device is already active, I don't need to do anything with the device. So therefore, yeah, there were some issues, but together with sublogic, they're quite easy fixable.
Any more questions? No? Excellent. Thank you, Anton.
Thank you very much.